Okay, let's get started here. And we're live. Okay. All right, where did we last leave it? Yes, okay. So we have we need to add the resolution, probably a file hash and a MIME type to the metadata struct. Now, I am not worried about developing a what do you call a script to build the database at this point. At this point, I'm just going ahead and making the adjustments using some of the tools I have, and then I'll export the data definition later. I still need to come up with something to handle database changes over time, but I'm not worrying about that right now. So let's go ahead, take a look at this. And so we want to add resolution to a SHA hash and a MIME type. Why would we add this at the metadata level and not at the file level? So the image level. So the image level is more abstract representation and could cover multiple encodings, which of course would have different hashes. This is meant to I think I'm going to change the name metadata. I think I'm going to change it to something like media source or something, but later. So right now, let's worry about so if they're the same file, they should have the same hash and of course the same MIME type, but they have multiple disk locations or multiple locations, say on APIs or file shares or what have you. So anyway, so we need to add the resolution, and we determined that a resolution is composed of a width and a height, and there could be different scans, right? It could be a progressive scan, it could be an interlace scan. With video, 1080i and 1080p are very different resolutions. So the question is, do I want to go in here and create a resolution type and map that type? Part of me is very much tempted to do that. What's our error in image.go? Oh, okay. So we got to this quandary by looking at the find method and realizing that we don't have a complete picture of the underlying data. So the notion that the same image could have multiple encodings hit the wall that we have no way of linking them together, basically. So as we worked that out, we discovered that really this data about resolution, hash, and type, MIME type, belongs at this level. Okay, so let's do that. Let's go ahead and where's modify tape? There it is. I'm blind as a bat. Okay. So we could definitely say we could add hash and MIME type are easy fields. So let's do those first. And then let's look at opening up a console. Oh, varchar. Now you may have noticed that I don't specify the size of the varchar because in Postgres that's really kind of unnecessary. So let's go ahead and create type resolution, and that's going to have, oops, width, and it's going to be an int. Height, int. Oh, how does this work? Semicolon? Height. I need to look at that up. So Postgres create type. Make sure we're looking at 13. So create type name as. Okay. And I believe they are separated by commas. Okay. Now let me go ahead and run this. So we have a type, and let's go back to editing this. Modify table, and let's add a column resolution. So, yeah, I hate stuttering, but okay, let's make that a resolution. Okay. So we see we've got all right. Now I believe oh, there's no module database here, so let's go ahead. So let's go ahead and create a module. Okay, now let's go check this. Okay, so now we're good. Yep, okay, we're good. Okay. Um, so we have test DB caller. Let's see what methods are here. That's interesting. So we define the mock metadata server, but down here, does not implement type metadata server. Oh, it's probably missing a method. Okay. Implement missing methods. Where's data 2 coming from? Just be data, 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 right? So okay, let's get rid of those. Okay. That is a single, right? Oh. There we go. Unused parameter context. Yes. Unused parameter context, yes. I think we can proceed with an underscore, right? And put underscore in that. Nope, that didn't do it. What if we just use underscores? There, now it's happy. So I like all my code to be very happy. Wow, totally missed that off the refactoring. Okay, so now we're back to image. Okay, back to image. Where do we map our data type? So what do we want to say? We want to say func map resolution type. And this is going to take what? This is going to take let's see what the API for that is. I think it's in PGX type. So looking at PGX type, let's see, there should be what's composite type? Let's go take just a PGX register custom type. Let's go take a look at this. Connect config, parse config, connect, close, deallocate, wait for notification. Config. Conduct go. Line 66, I don't think that maps correctly anymore. Let's see, let's see, sanitize, new, connect, Hmm. Okay. Hmm. Before connect hook. It's okay. That is no longer. Let's go to before. Oops. Let's see, we're on master. We want V4. Still have before connect hook. So let's take a look. Let's see. We've got our con. We have statement cache mode. Let's see. Do we let's go take a look at let's go take a look at connect config. Oh, let's take a look at examples. Let's just see something real quick. So this should take PGX pool. Pool turn. Just stub this out for now. Figure out how to do this real quick. Return nil. Pool dot. So what are the methods on pool? Here's before connect. So let's see. Config for connect. So we want to we want to create a config. So we want to go to pgx config. That runs a connection. So pgx pool. There we go. Can I fill in all fields here? Let's rename this con CFG. Let's see, CFG. Fill in all fields. So here we have after connect. What's after connect? After is an after connect func, which is something that takes context. Is there a similar structure for pgx pool? Yes, there is. Okay, so pgx pool has before connect and after connect. So let's see. Actually, go down here, wouldn't it? Yes, it would. So no, I'm barking up the right tree. So um, so here we have um, so we're going to have a function called dbConnect. It is going to take nothing, and it will return a db caller and an error. Okay, so this function is going to take a db caller and an error. So the first thing we're going to do is we're going to get our database URI and we're going to get that from, and we're going to call this and we're going to make this, all right. So if we don't have a DB URI set, then there's really no way we can continue. So we're going to go ahead and return nil, and then var error no database database URI not set, and we're going to make that equal to database URI not set. Okay, so we've got a URI at that point. So now let's look at making a PGX pool config. So let's take out this. We're going to call this func register. And the reason I'm making it private is this doesn't have to be exposed outside of this package, right? So when we register this, it'll just be used internally. So register resolution type, and this is before connect, which is takes a context and a PGX config. Right. And what does it return? An error. It returns an error. Okay. Okay, so what do we have here? We have a context and a config. So what is after connect? That takes connection. So that takes context and a connection. So con. Now let's see. So we got query, we got con config. Maybe it's from there. Huh, okay. So what does config return? Config returns a pointer to a con config. Okay, great. Maybe it's in con info. Register data type. So the type is going to be and a resolution is going to have a height and a width. Those are ints. And a scan, which is rune. And this is going to be resolution. Whoops. Nope. How do I do this? Type. Did I get the type? Let's see if we've got an example. Hmm. Okay. Let's go take a look. CRUD actions. Let's see, batch test, con test. Register data type. There we go. Okay. So let's go back to register data type. So value is pg type dot name resolution. And this would be so some type of composite type or something like that. Oidoid? What's an oidoid? Probably an oid that represents an oid. Okay. A recordoid? Sure, let's go with that. New composite type. Okay, this is going to take some research, but um, definitely want to transparently register the resolution type. Oh, redeclared. Definitely want to register that. New composite type. My guess. Okay, new composite type. Oh, resolution. Let's see, comp type. And the type of that was PGX, PG type, composite. Type field, right? This takes a, yep, yep. Name, width, and it take, did I do width and then height? Width, height, yeah. I don't think the order matters. And I think this is just a straight int4oid. And height. Yep. And scan is PG type care, BP careoid. All right. So fields. And con info. So that's con.coninfo. And that can return an error. I want to say that this is probably becomes comp type, right? What is comp type? Comp type is PG type composite type. What does register data type take? Maybe I don't need that because I'm passing in the con info. New composite type creates a composite type from the fields, and CI. CI is used to find the value transcript. Okay. Composite type. Let's see what it does. So there's our transcoder. for all the fields. Returns back a new type, but doesn't register it. Let's see, PG type, data type. Let's see if we just pass comp type. Nope, that's not the right type. It is not a value. Yeah. Where's the composite type weight? Okay, so error. All right, so at this point we're registered. No, that doesn't return anything. Okay. So what we want to do is call the connect config the CTX Yep. Big, right? Cannot use config, type config as conconfig. right? Okay. Cannot use config, type config. Huh. Looks like we're crossing streams here. Okay. Oh, I do not like it when it does that. Okay, that should be my database connection. This I'm going to test with an actual live database connection, so this is not going to be something I can test using mocking, right? All right. Well, in any case, that is it for today. It's more than enough. I need to shorten these, keep these down to half an hour.